engineering, and we got Chris Parker here to talk about that. Then when we come back from lunch, we're going to be doing computer science, and we have Will, who's going to be showing you guys some cool stuff with gaming, and he has a few models of some games he's going to show you guys. So today's going to be pretty, pretty jam-packed with good activities. We're going to start off with Chris Parker. Chris Parker, he's a STEM professional. He knows all about robotics. He makes video games, and he's going to tell you guys about robotics engineering and about other cool stuff. So, without further ado, Chris Parker.
Hello, good morning, everybody. I feel awkward giving such high afterward. But my name is Chris. I actually own a business. It's called Tech Roots, and I teach robotics and design, web design, and programming to people and kids your age, and younger and older. But today I'm here to talk to you about robotics engineering. Is anyone here considering being an engineer, computer programmer, graphic designer, anything like that? Quite a few. Oh. Okay, do you know what's required of you in order to go into those fields? I don't know what. I guess how many?
Around 13.
13. So you know what you might need to focus on studying to get into what was it, engineering?
Algebra and science.
Algebra and science.
Yeah, you need to focus on that.
That's good. Anybody else got a different field or a different thing you need to work on? I know some. I'm just waiting, trying to see what you guys already know, so I don't have to repeat information. Yes?
You have to know coding, a little bit about coding.
It will help you to know a little bit about coding. For engineering, you don't really have to know coding, but it will help you along the way. Because for robotics engineering, you work with programmers. A lot about robotics engineering is that it's pretty much a combination of engineering and computer science, and they just kind of mash it together. And so you'll have to program a robot, but at the same time, you need to know how that robot operates in the real world, and so how the motors are going to work, how the gears are going to come together, the gearing ratios, all those different types of things. And so in school, a lot of what you'll need to focus on would be physics, geometry, algebra, and some of just not too advanced math. You can get really advanced with it, but starting out, if you just know geometry, physics, once you get to physics, geometry and algebra really well, and know how to add, subtract, multiply, and divide, then you'll be on the right track. Science, you might do good to know some chemistry, just because it could never hurt. But you might, depending on what you do, you might not get too much into chemistry. If you're going into medical engineering where they have robots that do surgery, you might find more chemistry there, but or biology. But science, really physics, is what you'll have to focus on most. I'm going to show you a video that kind of explains what robotics is. And then we'll go from there. I'll have a couple of activities we're going to do, and yeah, hopefully you'll enjoy it. Without further ado.
A lot of people are worried about zombie attacks and vampires and other mythical creatures. But there's an actual possible threat that we at Epipio want you to be ready for. A future robot uprising. So to talk about this threat, we brought in a PhD in robotics and best-selling author, Daniel H. Wilson. And I asked him, what is a robot?
A robot is any mechanical artifact that can sense the environment, think about what to do, and then execute an action in the real world.
So what are some examples of robots that we're going to see in the future?
Humanoid robots, autonomous cars, consumer robotics that do special purpose tasks in our homes, more and more pets that are robotic, and toys, smart environments that we live inside of, so the actual places where we live are going to start to notice where we're at and what we're doing.
So how would I know if a robot uprising was happening?
You want to know what a robot's designed for, and if it's doing something that's outside the scope of what it was made to do, then you should be very suspicious. You also want to look for the telltale signs that pop culture has warned us of. So, glowing red eyes, spinning buzzsaws for arms, things like those are dead giveaways.
In the event of a robot uprising, what are some ways we can fight back?
If you find yourself fighting a robot hand to hand, you're in real trouble, because that's going to be an advanced humanoid robot. So you don't want to throw a punch at a robot, obviously. It's not made out of material that you're going to be able to harm. So your best bet is to arm yourself. A good general purpose rule is to always go for the sensors. A robot uses cameras and microphones to sense the environment, And although the robot itself might be very tough, the sensors can be either damaged or they can be tripped. Cameras are susceptible to flashes of light, things like that. Vision tracking systems are really cool, but what they do is they try to predict where you're going to be. So if you move in an unpredictable way, then it's going to make the humanoid have to search harder for you. Whereas if it figures out what your velocity is, it's going to be able to just look at a few steps ahead every second and then spot you again. And you have a lot of advantages in terms of running. Human beings are very dexterous mammals, typically much more dexterous than machines, which tend to be heavier and slower than people. So climb under a car, climb a tree, jump in water, swim. Humans are really adaptable to a wide range of environments, and machines are typically designed to operate in a narrow range of environments.
What if you want to do more than just run? What if you actually want to destroy some robots?
Any well-designed robot is going to have what's called an emergency stop or a kill switch. Typically in the lab, these look literally like big red buttons that you push. But you got to remember that a lot of times, even when you hit a kill switch, you could be in danger because that machine's now going to be inactive. If it's big, it might fall over and crush you. If it's carrying something valuable, it might drop that. So you got to think ahead.
So lastly, I think, is giant walking robots. These are probably going to be a problem sometime in our lifetime. At least I hope so. How do you take these down?
A giant walker is going to have very lightweight legs. And so this makes the legs a prime target for you as a person. So if you have a gun or some kind of weapon, you want to attack the joints of a giant walker. And the higher up that you get it, the better. Because if you can sever an entire leg, it's going to be much more helpless than if you just take off a foot. Because remember, a robot doesn't feel pain, and it can quickly adapt to locomoting with a new set of constraints.
Well, there you go. There's a little bit of information about how to survive Robot Uprising. If you want to learn more, check out his book, and Godspeed.
Let's watch it again. Let's watch
So
it out of
that is
10.
all of you that want to become robotics engineers. That is the danger you're putting us in by making us objective to these giant robots.
I'm not be making robots. I'll be making weapons.
You'll be making weapons. See, I'm scared of you now. I don't know if I should show you any more. Today.
Phil, chill with the evil laugh.
Sorry,
Sorry, not a good evil laugh.
I've
seen better. I've seen much better.
So, before you get to the point where you can actually make
Yeah,
weapons,
but no
or
one can see what's
can I have your attention? Just a second. So before you get to the point where you can actually make weapons or anything that can hurt someone with a robot or computer program, like I said, you need to focus on the things you're doing in school to get there. It can be a lot of fun. I can say for robotics engineering, the average salary right now is about 80 grand a year, and that's, I think, starting out for just somebody graduating college with a bachelor's degree. And so it goes up from there, and by the time you get to it, I'm sure it'll be much more than that because the demand will grow. For programmers, you get about 40 to or 60 grand starting out. You might start at 40 and then they up you to 60 depending on what you're doing and where you're going. Okay, and different things like that. So I guess any questions about this before we go into our little activity? I'm not good at the whole talking part and I don't have notes, so I don't have much to say. But any questions about robots, engineering in general? Yep.
So basically, we shouldn't create robots.
We shouldn't.
Because then if we create robots, we're just going to keep dying.
Well, no, that was just kind of an exaggeration for the sake of teaching what a robot is. There will be some that people make, there are some that people develop now that can be used to hurt people, but the general consensus among people that create them is they're not trying to create them to hurt people. They're trying to create robots to help people do things that are hard for them to do. For example, you have self-driving cars that Google has been developing for a while and other companies are developing. Like in California, they actually have it legalized that they can test the self-driving cars on the road. And it's come to find out that most of the accidents that the cars are involved in are because people hit the car, not because the car hits people. And so as that expands, we'll probably see a lot more self-driving cars around, which means you can use that, and that's a robot, but that means you can use it to do homework in the car on your way to school. If you're in college or things like that, you can go to sleep while you're in the car and not have to worry about getting into accidents and save you a lot of time in that way. Yes, you have questions?
In California,
roads, they're smooth, but the little parts kind of unrealistic because there are no potholes. It's like in sunny weather.
Are you sure about that?
Yes.
How sure are you about that? Do you live in California?
No.
No.
You don't. So can you say for sure, for a certainty? Yeah, I will admit that the roads are a bit better, especially from here. Our roads are one of the worst ever. But that is not 100% accurate because you don't live there, so you can't say for sure that they have no potholes whatsoever. But aside from that, I do believe that you might be true. That might be somewhat true, just not 100%. But even then, that's part of the challenge of the program. You have to design a car that can work on any type of road, regardless. You have dirt roads that the car needs to be designed to work on, roads with potholes. The car needs to, maybe it'll slow down when it notices there are a lot of potholes around. And if everybody's car is self-driving, then it won't interfere with traffic because everybody's car will be slower in that area. But you won't care anyway because you'll be in the car playing video games or doing something else. So that part won't come to bother you too much, and all you'll notice is a smooth ride. And so there are ways, but that's the challenge of it. You have to design something that will work in whatever situation you find it in, and that'll work across the board. Maybe they'll have a different type of self-driving car in California than they do in Michigan. Maybe the wheels on our cars will be more sturdy because of the potholes. Or maybe the government will actually fix the roads like they should, and we won't have to worry about that at all. But that's another topic. Any other questions before the activity? Anything you want to know about? Yes.
Do you think robots will start an uprising like in iRobot or Terminator?
Well, that gets into, there are actually different types for robots go. You have robots that are remote controlled, where somebody is operating, and that's what we've had up until, well, we have those now, and it's starting to switch into autonomous robots, which are robots that
Work automatically?
Yeah, they work automatically. You put in a program,
Artificial.
and they do what the program says, and that's really not artificial intelligence because we programmed it and it's doing what our program says. And then there's artificial intelligence where the robot actually learns like we do, and it learns that, okay, I can't walk through the wall, let me go around to the door and stuff. And so and I'm sure that, I don't know specifically how many types of different robotics there are. You got nanotechnology, which could be a combination of all those things. There's lots that's going on in the world. I just know as far as basic breakdown, you have the ones we control with remote controls. There are the ones that we program, and then they do what we program them to do. That's like car factories. They have the automated systems, and the cars go down the assembly line, and the robot drills all the bolts and things like that. And then there are the AI, which actually learn. IBM has it's not a robot right now, but they have an artificial intelligence called Watson. Have any of you heard of that? Okay, and what Watson does is just learns about stuff, so they can learn how to communicate with us better. Siri is an example of an artificial intelligence, or the start of an artificial intelligence. Cortana that Windows makes, the Google Now service is another example of that. I don't think they have a name for theirs yet. They probably will come up with one eventually. Yep.
Is it possible that the robots could learn too much and malfunction?
To learn too much and malfunction? I don't see that they would malfunction because of it. It would just make them smarter. The same way when you learn more things, it just makes you smarter. It doesn't cause you to have any issues. You just have more information in your head.
No, I think he means like, will they like go against this, like Ultron or Brainiac or something like that?
Okay, so that stuff is movies, and they do that because there's that fear that, like iRobot or The Matrix and things, that there's underlying fear that, generally we have because robots are metal, they're technically stronger than us, so if they were to go against their programming, then yeah, they could do us a lot of harm. But in those movies, they have a lot of much more advanced technology than we have today, and so some of the things that they do cannot really happen in the real world today. So like Ultron is a great example, but he would be like the perfect AI, but we don't even have artificial intelligence as a kind of standard among people yet. And so as that grows, that will become more of a fear, but then it comes to the job of the people that program the initial system to put in the safeguards to not let the robots allow that. And we'll put in morality systems. There are people working on morality systems for computers and things like that, to where they can tell what's good and bad. There's a lot of things as far as technology that's going on that are still brand new now, but by the time you get to it, it'll probably be more there for you to actually work on and learn about. Yes.
How do you say that human uses 10% of their brain? With a robot, how much percent they use for thinking and knowledge?
Well, a robot is essentially a computer, and it just has mechanical parts that allow it to interact with the world. Like I said, sensors in the video that lets it see, they had the picture of the robot sweeping up dirt and let it see that there was dirt there. So it was a sensor that allowed the robot, like our eyes, examples of sensors we have, our eyes, our ears, our nose, our tongue, and our skin actually act as sensors. Like this would be a touch sensor, a pressure sensor. You can tell when something's touching you and all that kind of things. Our eyes let us see vision like a camera would for a robot. And so, I forgot you must have Could you repeat it?
How much, you said that robot.
Oh, how much of the brain, right. So it would actually probably use 100% of its capacity because it's a computer, and so it would be based on, at least computers now, how fast it runs is determined by the processor and the RAM. And so if the robot has a great processor and a lot of RAM, it could run more processes quickly, and it can use more of its hard drive space and capacity to actually do more things. And so it's up to how they build the actual robot. Speak up. Speak up. Input. We had input. Speak up. So that everybody can hear you.
In other words, the central processing unit, the
CPU.
the core processor actually depends on how fast it thinks. So,
Right. Right. That's exactly right. The processor determines how quickly it can actually process information and how many cores it has really. And so they talk about computers that have 8 cores, and they're working on some that have 100 cores and all that kind of stuff. And then there's 4D, quantum computing, which is really, really awesome. Now, hopefully by the time you get to where you're working on stuff, quantum computing is the actual thing that's generalized because it's really cool. I'm not going to talk about that. That gets really confusing. The faster it can think. And so as it learns more information, that would be what makes it smart. So like how you go to Wikipedia, you can look up a bunch of stuff, and how you know about that stuff. And so the computer, if it had more cores, it could go through you might be able to go through 10 Wikipedia pages in 10 minutes. The computer might be able to go through 100, and then if you add more cores, it can multiply that to 1,000, and so on.
So it's like the Flash, but it's a little close.
Right, like the Flash, yeah. Yeah, that's actually a really good analogy. I should have used the Flash. I should have used superheroes. You can never go wrong using superheroes. So yeah, like how fast the Flash could actually read a book in an equivalent to a computer with more cores for processing. Anyone else with any questions? Okay, so we're gonna do our activity. About 15?
Got 17.
17?
You can maybe go 4 groups, 4 groups of 4 to 5.
Okay, that works. Do you let them move on, or do you pick?
How much about everybody know? We're gonna have 4 groups.
Explain activity.
Oh yeah.
Okay, so what we're gonna do is, since I was initially talking about robotics engineering, well, we're still talking about robotics engineering, we're gonna do an engineering challenge, and so, somebody has my bag. I'll get that in a second. But, no, it was,
I guess I'll ask them.
yes. He is guarding it well, I will say that. I asked LTU to guard my tools with his life. But the activity today, we're going to build a structure using the candy dots and toothpicks. And as soon as they get back with the bag, I can show it to you. But we're going to design something that holds up a cup. And so what you'll be doing is so you're going to get paired off into teams. And so the team's job will be to design a structure that can hold up a glass cup that I brought with me using just toothpicks and dots. This is an engineering challenge, and it's about the design of the structure. It is possible to do. And so how it's going to work is every toothpick will be worth 1 point, and every dot will be worth 5 points. And so as you add materials, you'll add points to your score. And then if you can support the cup, I'll answer your question just a second. If you can, there it is. So this is the cup that you'll have to hold up. Your group will have to design to hold up. It's fairly heavy, but for toothpicks and dots, it should be heavy enough to give us more of a challenge. And when I say dots, I mean the candy dots.
Yeah, I'm gonna tell you that.
I did not.
I have a feeling someone's just gonna like
We're
start
supposed
eating
to.
the dots.
Well, if you start eating the dots, your team will lose. I can guarantee you. And these, regular toothpicks, nothing special about them. Let me finish the explanation, then I'll answer the question, all right? So don't forget it. And so you'll be given, initially you'll be given about 20 toothpicks, and as you add more materials to the actual structure, you'll earn points. And if your structure successfully holds up the cup, I'll start putting in coins, pennies, nickels, dimes, and all those things. And as I put in coins, your score will go back down. So whoever ends up with the lowest score will win. And so you want to have the least amount of materials, but have the most coins, but still be able to hold the cup with the coins in it. Everybody understand?
Yes.
Okay, so we're going to break up into teams now.
We're gonna win 100 games.
Beautiful morning.
We're gonna win 100 games.
Wait, we
An
got
apple. And I got good apple.
They're my
Alright, our former speaker was talking about the dangers of robots taking over different machines and everybody else in the world, because here's the key. If you want your robots not to kill you or do anything crazy, make sure you have proper security in place in the software you actually put into the brain of the robot itself. So basically make sure that cybersecurity is upfront and personal once you get even into the coding process. So of course, when you go with cybersecurity, it also goes into the networks, including your Linux and Unix commands. So first thing you need to know is how to check the network status of the machines. So it's okay, netstat. And yes, I'm doing this Guitar Hero style. What? Because I kind of hold this like a Guitar Hero controller. And that gives you an idea what netstat looks like on a Unix or Linux machine.
Is that coding?
We're going to get to that part shortly. So I'll go a little about networks and that type of stuff here. So next thing, if you want to figure out if you want to do ipconfig, ipconfig if you're in a Linux Unix environment. So Windows user would type in ipconfig, or actually I'll type in ipconfig, so you guys know the right way of doing this. And there actually is some meaning to my madness, so I'll show you what ipconfig will do. And now I'm going to ask a few generic questions here. And my CD-ROM over there doesn't choke on me first. So of course I had to throw in a quick meat-headed question in this game. Pretty much ask you what you need to do to build muscle. So first thing you ask, hey, to build muscle to hit weight? Nah, change your program a little bit, makes the most sense. So I hit 2. So basically this program, as I said, it'll pretty much show you some good imagery. If you get a good answer and bad images, you get a bad answer. And for some reason, the sound is not working. So put this quick little interface for you guys. So now I'll type in a bad answer. And I'll show you something a little bit more graphically intense and then go into the code portion right afterwards. So basically, guys, this is a quick, simple program that I built C++. And after going through different command prompts and everything else and different software tools, you have to run on this right here in my hand. So what you see on the screen is actually running off the Sega Dreamcast. So I typed in the wrong answer. I was like, you know what? Let's say, hey, you typed in the wrong answer. I'd say, you know what? Fail. And huge fail with Apple. So then that's another jibber-jabber on that. So let's get to the details of the presentation and switch machines.
I have a question.
Sure.
What did you put? Do you have to put something in the Dreamcast?
Actually, good question, because you can either use a modified USB connector that goes to the serial port in the back of it. And you'll notice the Dreamcast actually has this connection like right here on the back. So you have your power supply and your video. Serial port is there. Get one of these online, and the nice part about this adapter is the fact that when you open it up, there actually is a portion of it that lets you hook in the SD card. So basically you can copy your code to the SD card and pop it in there, or you can use different tools I'll go over later on, and then just burn like a regular disk like this, and it actually will run on any Dreamcast that has a Model 1 on it.
Oh, so you have to put like a regular CD into it?
Yep, regular CDR works or a USB stick works. Yep, so now we need to switch over to computer and we should be good to go. Continue this on. So basically what I just did, I kind of just built a quick game with the Dreamcast. So if you guys want to do this at home, a few things you may want to need will be on this list right here. So of course we need actual Dreamcast like I have right in front of you. Or you can look online and get a Dreamcast emulator. Just make sure you do a good virus check before downloading it. And then there's even some programs I've been on as boot dreams, and that's something we actually would need to actually convert all the files from what would be on the PC to something the Dreamcast actually understand. So that's also a good thing. And of course, actually build your programs. You actually want something known as Turbo C++ actually build your code. So most programming languages that you'll actually use to build software nowadays would be basically you type in some different syntax, and the syntax was actually translated to computer code. So basically it translates what you're trying to tell the computer to do, and as it moves, boom, which it comes up on the screen. Like I showed you an example earlier. So then the easiest way to do it will be to actually go into a compiler right now. So go ahead and show you guys Turbo C++ now. And this one I just open up a random program that I built earlier. So this shows you the real old school way of programming. So we have struct right here. We're going to simplify this a little bit to show you like, hey, you just want something to show up on the screen like I showed you guys with the craziness, with the little text mode stuff. Basically, I just created like a function right here, do a whole bunch of cout statements, and cout is kind of like, okay, C++ out input output. So input is what you tell the computer to do, and output is boom, what you get out on the screen itself or out on a piece of paper. So on C++, you have something known as a CN, which basically you're typing into the computer, so it's this input. Cout will actually come out of the machine later on. Here's a little ASCII text right here to do a little quick intro, but that's not really serious. So basically the biggest thing with most games is, of course, you want to have something with integers to store values. And most importantly, just to give you an idea of how the game itself works, we did something known as your if then else statement. So, hey, if you have a good answer, boom, you get a good result. Bad answer, bad results. So of course, if I say, okay, if someone typed in netstat, they'll actually get the information they want on the screen. So basically call that function to display netstat. However, they had a bad answer, it's a sorry, wrong answer. So it's all about just making different decisions and that type of stuff. Then of course, the C++ has something known as your header files. So of course, as you get the graphics to show up like the little image that show up on the screen, there's something known as the graphics.h. So basically, graphics.h looks in the actual graphics library that's actually in the old school version of C++, and it says, hey, guess what? This is code you need to do to actually make a bitmap image actually render on the screen. And of course, bitmaps just use something like Microsoft Paint. You can easily build it with that, no issues. Just make sure that the platform you're trying to build it for actually is in a format that you can actually understand. Go ahead and put out of here. And rather than bore you guys to death too long with the C++ explanation, have something that's a little bit prettier, a little more graphical with NetBeans, show you different things. You can pretty much run anything that has an x86 processor or ARM chip installed on it. So let's say you build something in Java, it'll run on anything that's Windows-based, Linux-based, or of course Mac OS X, as long as you have the Java runtime environment installed on your computer. So this game originally built within Java. It's going to take a while for us to load up. And rule of thumb is anytime you do a technical presentation, seeing your computer will load everything 10 times slower than normal. So please bear with me. but it's the same idea where you pretty much have to set up with different integral values. So in this program, I actually have two integers that are actually public classes described in Java, or if this is in C++, it actually would be pretty much our global variables. So two global variables I created here were int qnum as well as int score. Qnum is basically telling, hey, guess what, this is the question number. So it's like, okay, we have an integer to keep track of how many questions we have in the game, and then of course the integer value pretty much keep track of that score itself. And of course, we even have something here, you guys may recognize later on, I actually play a sample. Pretty much, we say, hey, guess what, during the whole game, we should actually stream this wave file, or this audio file. Once again, make sure you have a type of input file that your system is going to recognize. With Java, this is your safest bet, is just make a regular straight wave file. So let's say you have an MP3 file, you actually will open a program known as Audacity or some consumer tool, convert all your MP3s to waves. And this kind of feeds into what was mentioned earlier on in the DJing session you guys had earlier this class period. Well, anyway, let me show you what this game looks like once you control everything and get it running. And once the thing boots up, that audio should sound familiar.
Oh, that's familiar.
Yep. So basically, I extracted that audio and then kind of mixed it in a few video clips to build this. So I have a few classes built inside that actually look for a video file to get that image to come up on the screen. And of course, with any other game, you will hit start it. And here I was like, ran out of video footage from the class, so I said, you know, let's go with some random footage. So chose Big Bugs Bunny because hey, it's free and open source, so threw that in there. So of course, during the interview, you should pretend to be Superman. Act like you're basically scared of everything, launch your gold chain, or be open to both your strengths and weaknesses. Should be open to both your strengths and weaknesses, so. And of course, during the job interview, you should provide the person you're doing an interview with which of the following: resume in a folder, a double cheeseburger, a bar of soap, or a mint. You know what? We're going with the bar of soap. And of course, Ryan the base support does what? Does it make something more stable or less stable?
I saw that.
Ryan base support? More stable or less stable, guys?
Less stable.
Let's see. Nope, it's a less stable, which is why you have video footage of me doing a failed push-up. Okay, which is faster, virtualization? Okay, we didn't go over that side. Skip that one. Okay, for a stable building structure, what do you need? You need a pre-design, a 4-bit architecture, a bunch of sandbags, or a solid foundation. So this kind of goes back to that toothpick, the possible thing you guys did earlier.
Solid foundation.
Solid foundation, that's correct.
All right.
Alright, which color is not a primary color in the spectrum? I think it was teal.
I probably. Which one? TV.
And this video that me and my buddy did on YouTube a while ago. So basically, we took his lyrics with free open source beat notes out there, just mixed it all together. And we used Audacity to make the actual audio file. And this is a previous recorded video, that's why you saw the 2015 date in there. So, any questions? Go ahead.
Can you like ever hack like the game?
It's possible. Considering I hacked the entire console to get that one game to work, you can definitely hack plenty of games that are out there.
Are you using that?
Huh?
Are you using that like?
Oh, for this I just use like, actually builds I use NetBeans, and for me it was the easiest thing to actually build games with because, you know, it's free and open source and it pretty much runs on everything. And then I use Turbo C++ because that was the easiest C++ compiler that actually is compatible with multiple pieces of machines. Any other questions? Ready to go? Yep. All right.
Guys, is everyone in here? Okay. This is going to be a quick presentation about coding and how it's interactive. The interface I'm using is GameMaker, but GameMaker has like a drag and drop thing as to where you can easily program games. Like, let me just pull up a quick. Like pretty much like this drag and drop variables, but like that's just basics of coding. So you guys can easily get into that. What you guys doing?
Yeah, it's like we chasing each other around.
But this game right here, although it still doesn't work, it's strictly code as where I can easily pull up and see some variable codes as where I'm setting up pretty much all of this stuff right here. But that's just the simple and simplistics of it. There's more coding as where you can go online to a place called Code Academy. They can teach you JavaScript, HTML, C, C++, Python, and they're up to date with all their coding. It's called Code Academy. It's online. You can get an account for free and everything. Same with downloading a GameMaker. That's free as well, unless you want to do a little bit more. Then they start charging you, which if you want to do more stuff, I see that personally. Other than that, I would like to have a volunteer to come up and test this game. No? About it. Alright, come here, I'll show you. A space bar to shoot, do right here to move around. Alright, these are the control right here to move, this is shoot. That's all you need. Are you ready? Okay. Now press play. And go. Yeah, there you go. And as he's playing it, I just want you guys to know that this game was also used by a lot of the block setup, as to where GameMaker has a tutorial form as to where if you don't really know code as much, it's there so that you can actually build the game from blocks of code. But you can also go in the game itself and actually learn what code it is. So then when you want to make a game strictly in coding, you can easily drop the script for it and then code from there. This is a game I'm trying to have as an app, just trying to learn. Though there's another version of it as where it's not requiring the keyboards, but it's requiring you to use the mouse. But for now, that's all I have so far about the game. Still in work in progress, but this is what I have so far.
I'll try. No, I'm a real cold.
Yeah. Okay, as you can see there, the ship right there should change to a different color and it fires different things. That's another unique thing I have about the game. Any questions so far? Phil?
Can I play next?
Question? You want to play next?
There's another website. It's a better website.
Oh, okay, yeah.
Good job.
Hey everybody, I want you guys to all get a chance to play some games. So we have Malik's laptop set up for games, and I got my laptop set up, and Shai's laptop set up. So we're gonna kind of like go back into your groups, and everyone will get a chance to like play the different games. So if you remember your groups, you guys can start at one second.
Yeah, they're cool with that.
Just let them play the game and have fun while doing it. Knew it. What type of muscles are fast twitch? I didn't even know.
Last day for this section of the program, but we're going to be transitioning like next year to bigger and better programs, more activities. You guys are going to actually be able to establish an e-board here at the Field Zone, where you guys will have a president, a vice president, treasurers, and all the different positions. We plan on taking you guys to like a fall regional conference and maybe national conference where you guys will compete with other organizations with different events and different activities. And next week we're going to have the commencement. It'll be from 11 to 12:30 at the campus of LTU. Please see Linda for the different the flyers for everything. And we'll see you guys next week. And, yeah, it's gonna be a formal event. So if you guys come with your suit and tie, or if you got like a nice shirt and tie, ladies, something nice dress,
Nice shirt and
and they'll be awarding you guys for all your hard work these past 10 weeks. And I just appreciate you guys making your effort to come out here every Saturday. And I just appreciate you guys, just your spirits. You guys are really good kids, and I hope you guys just go on to do great things. And we're gonna continue to work with you guys throughout this whole process. So thank you guys for a great segment, and I'll see you guys next week. We'll see you guys next week.
Okay, we have a couple quick announcements. The first one being at the Professional Development Conference. We'll be headed by NSBE, SHIP, as well as SWE, and we'll be in downtown Detroit, Michigan, 2 weeks from today, as well as Black Data Processing Associates. We'll have their next meeting on the third Thursday this month, dealing with tools for small businesses, and that basically wraps up everything. Thank you guys for watching, and please have a good day.